A smooth sphere of A of mass 2m is moving with speed 4u. Collides with a smooth sphere B of mass 3m moving with speed 3u. While B and A seem to be moving in opposite directions according to the arrows. Before the collision, the spheres are moving in opposite directions, with their centres tracing parallel paths 6a over 5 apart. As shown, the coefficient of restitution, the E value is 1/7. Show that the magnitude of the impulse imparted to each sphere due to the collision is 192 over 22 mu. Okay, so the first thing we're going to do is we're going to draw a quick diagram of them just as the collision occurs. So we have two spheres like so. I'm going to draw, at collision, they're going to be obviously in contact with each other, like so. And this is their centers. Now the difference in height between the two centers is given as 6a over 5, which would be something like this. So that's 6a over 5. If they're both radius a, then that's a plus a. That will make the whole thing 2a. And what we can get is an angle theta here. Okay, so theta, or sine theta, is 6a over 5 divided by 2a, which is the same thing as 3 over 5. So now we know that sine theta is 3 over 5. Sine theta is 3 over 5. It's going to be a 3, 4, 5 triangle. 3, 4, 5. We know that cos theta is going to be 4 over 5. Using Pythagoras' theorem, we found out that was 4. And then tan theta is 3 over 4. Probably don't need tan theta though. Now, what I'm going to do is I'm going to propose that we rotate the full question an angle theta anti-clockwise. So essentially what I'm doing here is I'm rotating it so it's flat like this. If that makes sense to you guys. Okay, I'm going to take a picture of this now. I'm going to use it. Okay. So that's what I'm going to use there. Send the current page. Okay. So that's the picture I'm going to use. Okay. So when I do this, what I've essentially done, one's going to 3u, the other's going to 4u. So what I've essentially done is rephrase the question using with everything, the line of centers being directly horizontal. Okay, this means A is angling up at theta and B is angling down at theta. Okay, it means I can break up their speeds. So for example, A, which we knew is going 4u, if it's going 4u in this direction, I can use theta to find out the two angles now. So it's going to be 4u, this is 4u sine theta, and this is 4u cos theta. So 4u sine theta is going to be 12 over 5u. So this one here is 12 over 5u. This one here is going to be cos theta 16 over 5u. And then the second sphere, which is now angling down at 3u theta, that's going to be 3u cos theta and 3u sine theta. 3u cos theta will be 12u over 5. Yep, so that'll be 12u over 5 for that one. And this one here will be 12u over 5, and this one will be 3u sine theta, which is 9u over 5. Okay, so what we're going to do next is we're going to do PCM and NEL using this. Now we're going to do a before and after picture. I can now get rid of that. I have everything I need from that now. So the before picture looks something like this, and the after picture. So it's 2m and the other one's 3m. So this one's mass 2m, The other one's mass 3m. This one's going across at sorry, I used the blue for it. This one's going across at 16u over 5 and is going upwards at 12u over 5. While the other one is going to the left at 12u over 5 and is also going down. Oh, sorry, I usually do it that way. And it's going down at 9u over 5. Which means it's going overall, it's going downwards like that. Okay, so we know that the y components stay the same. So these guys are going to be unaffected. Now what is going to be affected, however, is the 12. Sorry, what's going to be affected is the 12u over 5 and the 16u over 5. They're going to get affected. Okay. So then for the after picture, we're going to be using phi1 and phi2 for the x components. Okay, and the y components stay the same. So let's do PCM to start off, principle of conservation of momentum. So okay, so let's try this out. We're going to go for 2m, mass times velocity, times 16u over 5, plus 3m times 12u over 5 equals mv1, which will be 2mv1 plus 3mv2. Okay, all the m's can cancel, and what we get is 2v1 plus 3v2. Well, that's going to equal 2 times 16 over 5 plus 3 times what's it, 2u over sorry, no, that's not 2u over 5, that's 12u over 5. Just double check with your, yep, 16 and 12u over 5 over 5. Put it into the calculator and we get 68 over 5 for that. Okay, so 68 over 5. Now we're going to do NEL next. Newton's experimental law, so it's going to be V1 minus V2 equals minus E into U1 take away U2. So we have V1 take away V2. And now we're going to have minus EU, so it's going to be, I think it's a seventh to my knowledge. A seventh, so it's going to be a seventh. U1, which is 16u over 5, take away U2, which is, oh sorry, it's adding TL U2 because it's technically minus 12u over 5. Sorry guys, I believe I made a mistake up here. It's actually minus 12u, so that's my fault there. It's actually minus 12u, so remember that calculation I made earlier? It's actually a minus 12. Minus 4 over 5u, that's my bad there guys. Minus 4u over 5 for the first equation. So the first equation has to be the same. Okay, my bad. Now it's a double negative for this one, so it's minus 12u over 5, which is plus 12u over 5. Okay, so phi1 take away phi2 is 1/7. 16u plus 12u is 28u. over 5 minus the 7th. Keep forgetting the minus 8. So we're going to get v1 minus v2 is minus 4u over 5. So there we have it. We have a simultaneous equation now. So we're ready to find the velocities after impact. So multiply the bottom one by 3. So we get 2v1 plus 3v2 equals minus 4u over 5. Multiply the bottom one by 3, we get 3v1 minus 3v2. Then multiply the bottom by 3 here and we get minus 12u over 5. And then we should get 5v1 minus 16u over 5. v1 equals minus 16u over 5 divided by 5, which is minus 16u over 25. Okay, now we're going to find q. This time we're going to multiply the bottom equation by minus 2. So we get minus 2v1 plus 2v2 equals 8u over 5. Then we use the top equation, stays the same. And then we find out that 5v2 is 4u over 5. And then v2 is 4u over 25. Okay. Now, is that a plus or a minus, however? And that's a plus. Okay, so after collision, what's happening here is the 2m, this is the 3m. The 2m is going to the left with 16u over 25. The 3m is going to the right with 4u over 25. They're both still going, this one's still going upwards with, what is it, with 12u over 5. And the other one is still going upwards with, or downwards with 9u over 5. So this one's 3m's traveling diagonally right and down, and the other one's traveling diagonally left and up. All right, but that's not what we're asked. We're asked for the impulse exerted to impulse imparted to each sphere during the collision. Now, impulse is basically change in momentum. Okay, so change in momentum, and you can do it along the x-axis to my knowledge. So impulse equals change in momentum. Now the reason why you don't have to include the y values is the y values stay the same, so there is no change, so nothing to worry about there. Now impulse is the maximum value. It's mv minus mu, or it can be mu minus mv, but you're taking the positive value. So the impulse of the 2m mass is going to be 2m multiplied by v, and for the, we know that's 16u over 25, and then take away, oh sorry, that's a minus because it's going left, and then its initial speed was 2m and it was going 16u over 5 to the right at the start, so it's going to be 16u over 5 to the right. To the right, that one's to the left. Put it into the brackets there. So it's going to be both of them are going to end up adding together basically. So it's going to be 2 times minus 16 over 25, and then minus another 2 times 16 over 25. Oh, sorry, minus 2 times 16u over 25 minus 2m times 16u over 25. That's 64 over 125. Give me 1 second, trying to figure this out. Sorry guys, this is actually a 5, not a 25. 16u over 5. Remember at the start, there it is there, 16u over 5 at the beginning, not 16u over 25, 16u over 5. So that was why it didn't work out there. So let's try this again. 16u over 5. There we go, 192 over 25 mu. Okay, I would also do the 3m mass just to show you that it also works. So the impulse of the 3m mass is going to be 3m times its final speed, take away 3m times its initial speed and get the absolute value of that. So it has to be positive. So in this case, it's going to be, 12u over 5 at the beginning. And then at the very end, we knew it was 4u over 25 to the right. So 3 times 4 over 25. It's going to the left, so that's negative 4. It's hard to keep track of these. Negative 4. And then minus 3 times 12u over 5, so 12u over 5. Hope this has to be 192 over 25 as well. Yes, it is. There we go. 192 over 25. And there's your two impulses, okay? Happy out. Long question.